So for these examples, the first thing that we want to do is factor out our GCF. The first one is just going to factor out with a normal x, and so we can write it as x squared minus 2x minus 24. And then from here we can go ahead and figure out that we can factor this a little bit further. Remember that this sign right here tells us that when we do our binomial, our signs are going to be different. So I can set that up. One's going to be positive, one's going to be negative. And then the next one is going to be that the biggest number has to be negative. Otherwise, it won't work out. So if you remembered how to do this from Algebra 1, then you can just do it with that method. Or if you forgot, you can just simply do the diamond method or the X method, depending on how you were taught it. And that's when you take your B value and put it on top, and then you take your C value and put it on the bottom. The bottom one, you figure out what your factors are. There's 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I think that's it. So we can look at which one of these combinations, if we add or subtract, give us to our top number. In this case, it'll be 4 and 6. And as I mentioned before with our sign right here, I said it has to be the bigger number needs to be the sign. So we would set this up as 6 right here because the bigger number is negative, and then 4 is right here. And so this becomes our answer. All right. And the same thing is going to happen over on our next example. The only difference is that this one is a special factor. So again, before we start, we have to factor our GCF. The GCF of this one, remember, your variable GCF should always match your last term. So I know for a fact that I need to factor out p cubed. Then after that, I can look at my two numbers and I can figure out, okay, well, what is the number that I can take out between 3 and 192? What is my common factor? What is my greatest common factor between 3 and 192? And obviously for 3 is the only option, and I can check 3 with 192, and it does actually work out. It gives me a 64. So that means I factor this out. All right, so that means I need to rewrite this one, which is just going to become p squared minus, and then I need to rewrite this one, which is going to be just 64. From here, I can factor this portion out even further. So I carried on my GCF. If I want to do my special factors, I can do that. It's the difference of squares. But if I don't want to do that, I can just set up the diamond again. I can see that there is no B value, so it's 0. My C value, again, is 64. And from here, I can say, oh, well, I know that my signs are going to be different. And so I can do the factors of 64. 1 and 64, 2 and 32. I can try 3, but that's not going to work. 64 and 4, that'll give me 4 and 16. 6 isn't going to work. I can try 7, but that's not going to work either. I can try 8. 8 will give me 8 and 8. So again, I can ask myself, well, what two can I combine to give me the top, which is 0? And in that case, it's going to be 8. So this will be p plus 8, p minus 8. And so this becomes my answer. The last one is the same exact thing as our first example right here. We'll say this is example 1. The only difference is we have a value for a. So first things first, factor out your GCF. Remember, your GCF should match your last variable. So I know I need to factor out a x squared. And if I look at my 2, 9, and 18, the GCF for that is 1. So I can't really do anything for that. So I need to rewrite this one. After I factor out my x squared, that's going to give me 2x squared. Then I need to factor out this, and that's going to give me 2x. And then finally, I need to factor out my last one, which is just going to be negative 18. Now that I've done this, I need to set up my diamond. And I can put my B value on top. And the bottom of my diamond is actually the same thing that I've been doing, like what I did with the negative 24 and with the 64. But this time I need to multiply it with the A value. So it's going to be negative 18 times 2. So that'll give me a negative 36. And really the same thing was happening over here. Negative 24 times 1 is negative 24. So that's the same exact thing. It's just we didn't quite see it. It wasn't as obvious as the previous ones. So again, I do my factors of 36. I go to 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't work. I can do 6 and 6, and then that's it. So every single piece I can set up. Again, from my equation, I can see, or excuse me, not my equation, but my expression, I can see that this sign tells me that my signs are going to be different. So one's going to be positive, one's going to be negative. And it tells me that my biggest sign, this one tells me that my biggest sign has to be this sign. So I know that the biggest number needs to go with my positive. So I can put like a little underlining here, or if you're worried about that, you can put like a little star or something to help you remember the bigger number has to go there. So again, we look over in our category. We can figure out, okay, what two combinations get me a positive 9 by adding or subtracting. And if I look at it, it's pretty clear that if I add in, or actually not add, but if I subtract 12 minus 3, that'll give me my 9. So again, my biggest number goes with what I started earlier. Okay, and now everything seems to be pretty much done, except the problem is we need to finish this up. This is our not upside down division. This is our, I taught it as slide and divide, but I think you guys learned it as bottoms up. So we created that, but now we need to do the bottom portion. And how we do the bottom portion is we take our a value and divide every number by a value, which makes sense because we multiplied it in at the beginning, and now we need to divide it out to balance our equation. So when you do that, well, I just dropped something. But when you do that, if your number turns out to be perfect, then you're good to go. But if your number ends up as a decimal, then unfortunately, you can't actually do that. It's just complicated. So they ask that you just put it bottoms up. So let's look at the first one. We carry down our GCF. Here we have the first one. It says 12 divided by 2. That works out perfectly. That gives me 6. No issues. The next one gives me 3 divided by 2, which is 1.5. So that's an issue. So you're going to take that division piece and you're just going to put it in front. It's going to say 2x minus 3. And this becomes our answer. This should help you in the homework for section 4-4 for problems numbers 5 through 12. So good luck.